Dear students, welcome to my 5th class on Module 5, Sampling Theory. In this lecture video, we're going to discuss about chi-square distribution and problems on chi-square distribution. What is chi-square distribution? The chi-square distribution provides a measure of correspondence between theoretical frequency and observed frequency. If OI, where I is equal to 1, 2, n is an observed frequency, and EI, where I is equal to 1, 2, n is an expected frequency respectively, then to calculate chi-square, the formula is given by summation I from 1 to n OI minus EI whole square divided by EI. So here this n minus 1 is the degree of freedom in the case of chi-square distribution. And better note that this chi-square distribution will be applicable only if the sample size will be less than 10. So this is called chi-square distribution table, and to solve the problems we will be make use of this chi-square distribution table always. Example number 1, a die is thrown 264 times and the number appearing on the face follows the following distribution. So x is given like 1, 2, 3, 4, 5, 6 and f is given by 40, 32, 28, 58, 54, 60. Calculate the value of chi-square. So to calculate chi-square, first we must have the observed frequency and expected frequency. So I'll be taking the observed frequency of the given data only, that is OI will be equal to 40, 32, 28, 58, 54, 60 with respect to 1, 2, 3, 4, 5, 6. So now our job is to calculate the expected frequency. So to calculate this one, I am going to divide this 264 with trials with these numbers. X is equal to 1, 2, 3, 4, 5, 6. So we'll be getting the expected frequency as 264 by 6. It will be equal to 44 each for x is equal to 1, 2, 3, 4, 5, 6. So therefore, so at x is equal to 1, we have yi is 40, ai is 44, x is equal to 2, oi is 32, ei is 44, x is equal to 3, oi is 28, ei is 44, x is equal to 4, oi is 58, ei is 44, x is equal to 5, oi is 54, ei is 44, x is equal to 6, oi is 60, ei is 44. So now we'll be calculating chi-square value. So chi-square is given by summation I from 1 to n OI minus EI whole square divided by EI. So I can take 1 by EI common factor, that is 1 by 44 common factor. So simplifying that, OI minus EI whole square for each term will be getting 16 plus 144 plus 256 plus 196 plus 100 plus 256. So hence the value of chi-square will be equal to 22. Example number 2, a 5 dice were thrown 96 times and the number 1, 2 or 3 appearing on the face of the dice follows the frequency distribution as follows. So the first case is the number of dice showing the outcomes like 1, 2, 3. So it is 5 dice, 4 dice, 3 dice, 2 dice, 1 die and 0 dice. The frequency with respect to these x values will be 7, 19, 35, 24, 8, 3. So now test the hypothesis that the data follows the binomial distribution. With respect to chi-square is equal to 11.07 for 5 degree of freedom. So 5 degree of freedom means n will be equal to 6 here, because yeah. So now here, so first thing is we have to calculate the observed frequency and expected frequency. As we know that the given data will be always the observed frequency 7, 19, 35, 24, 83. So now to calculate expected frequency, I am going to frame the binomial distribution formula. So take the formula of binomial distribution and calculate the value of the expected frequency. So now, as we know that, so first thing is define the events P and Q to frame the binomial distribution formula. So I'll be taking P is equal to the chance of getting the numbers 1, 2, 3 on a single thrown die. So like throwing a die one time, we'll be having the possible outcomes are 6, that is 1, 2, 3, 4, 5, 6. Out of the 6 outcomes, choosing 1, 2, 3 as the outcome is 3 out of 6. So P will be equal to 1 by 2 will be getting. So we got P is equal to 3 by 6. So P is equal to 1 by 2. So once P is 1 by 2, Q will be always 1 by 2 because Q is equal to 1 minus P. So now take the binomial distribution fit, that is capital N into Q plus P whole power n. So it will be equal to 96 into 1 by 2 plus 1 by 2 whole power 5. So now I'm going to calculate the expected frequency by replacing x is equal to 5, 4, 3, 2, 1, 0. So at x is equal to 5, so we'll be getting the value like this. At x is equal to 4, at x is equal to 3, at x is equal to 2, and so on. So after simplifying this, we got the value like expected frequency like 3, 15, 30, 15, 3, and so on. So now I'm going to frame the table one more time. So therefore the observed frequency is 7, 19, 35, 24, 83, and the expected frequency is 3, 15, 30, 30, 15, 3. So now our job is to calculate the value of chi-square and testing the hypothesis. So chi-square will be equal to summation I from 1 to n OI minus EI whole square divided by EI we got. So by replacing all the values over here, so we got 16 by 3 plus 16 by 3 plus 25 by 30 plus 36 by 30 plus 49 by 15 plus 0 by 3 is equal to 11.7. So hence we got the chi-square value 11.7, which is greater than of the 11.7. So hence we can say that the data is not following the so hence we can conclude that the given data, what they have given data here, it is not following the binomial distribution, and the hypothesis is rejected here. Thank you.